Hello, everyone, and welcome to chapter 21, which will be on water pollution. I'm going to get through these final couple chapters relatively briefly. We'll look at the types of water pollution, water quality, and how we can improve water quality. The coal ash spill in the Dan River in Virginia and North Carolina was in January of 2014, where 30,000 gallons of coal ash were actually dumped into a river. And the solids left, these coal ash is actually solids left over after coal is burned, and they can contain toxic and radioactive chemicals and heavy metals. Water is used in fossil fuel extraction, and it produced a huge amount of water pollution. So we have types of water pollution being any physical or chemical change in the water that adversely affects health of humans and other organisms. And we have 8 categories of pollutants. Many can overlap, and you can see those categories of pollutants shown there, all the way from sewage to inorganic to organic compounds and thermal pollution. And we'll go over those briefly now. So sewage is the release of wastewater from drains or sewers. And this can be harmful because many times they can contain disease-causing agents. They can cause 2 serious environmental problems: enrichment, which is fertilization of a body of water, and the increase in biological demand, where the amount of oxygen needed by microorganisms is increased to decompose the extra biological wastes. And as that biological oxygen demand increases, the amount of oxygen will decrease. So here we have sewage and the concentration and the amount of distance downstream from the sewage spill. And you can see that biological oxygen demand and the dissolved oxygen. And you can see how it can kill fish as well. Oligotropic sewage is when you have unenriched clear water that supports small populations of aquatic organisms. But with eutrophication, we have a slow-flowing stream, lake, or estuary, which is enriched by these extra sewage, inorganic plant, and algae nutrients like phosphorus. And this can cause an over-nourishment of nutrients due to human activities. Infectious organisms can cause diseases that can originate in the wastes, and common bacterial or viral diseases can be typhoid, cholera, dysentery, polio, and hepatitis. And you can see those disease-causing agents that can come from the sewage and infiltrate the water, as shown there. So we can monitor this by testing for the presence, and this testing can indicate presence of pathogenic organisms like E. coli. Sediment pollution is when there's excessive amounts of suspended soil coming from maybe erosion from farms, forest soils, degraded stream banks, overgrazed rangelands, and so forth. Problems from sediment pollution are that it can limit light penetration, cover animals and plants, and then bring insoluble toxins that cannot disintegrate into waterways. 7% of sediments in the U.S. watersheds will seriously contaminate the water because they are filled with toxic pollutants. So then eating fish from these water-infected sediment pollutions could threaten human health. And you can see how the sediment prevents light penetration so that it'll kill all the plants below. Plant and algae nutrients coming from nitrogen and phosphorus, from human and animal wastes, plant residues, fertilizer, and so forth. Inorganic plant and algae nutrients can create a dead zone. So livestock produce about 20 times more feces in the urine of humans. Laws do not require waste treatment, and high of this zone can result in hypoxia, where you have very low oxygen zones, and that will affect how organisms and animals live there. So we have the inorganic Mississippi watershed coming from the runoff, a lot of the Great Plains and farmland. Organic compounds are chemicals that contain carbon and hydrogen, and these could come from pesticides, solvents, industrial chemicals, and plastics. VOCs, or organic compounds that easily enter the air. Endocrine disruptors are organic chemicals that mimic hormones that can affect human health as well. And chemicals are always measured in parts per billion or parts per million. And some chemicals cause problems at even very low concentrations. So here we have volatile organic compounds in the groundwater as shown as the dots. The red dots stand for 10 per liter or greater. Inorganic compounds contain elements other than carbon, like heavy metals, acids, and salts, like lead found in old paint, or mercury. And then radioactive substances contain atoms of unstable isotopes coming from mining, processing these materials, medical research facilities, nuclear power plants, and natural sources. Thermal pollution occurs when heated water produced during industrial processes is then released. So the increase in temperature can also affect reproductive cycles, digestive and respiration rates of these organisms. So in general, in summary, anything that we release into the ground can affect the water, and that could have negative effects on human and organism health. So we have two types of water pollution, whether it's point source, where that pollution can be traced to a specific origin, or a non-point source, where pollutants entered the body of water over large areas rather than being concentrated. They can diffuse, but the cumulative effect is still large. Agriculture is the leading source of water pollution in the US, as you know, and 72% of all water pollution in rivers is from agriculture. Municipal water pollution, so sewage treatment is a point source, urban runoff is a non-point source, and the combined sewer systems are when we have human and industrial wastes combined before they're sent to the wastewater treatment. Infrastructure is old, and processing in this water treatment can be backed up, and high rainfalls can also overflow the sewages as well. So here we have the municipal water solution showing how sewages, which will be taken to a water treatment center, can also have extra runoff, which will go directly into streams and waters. Industrial waste, so different industries generate different pollutants, whether those are food processing plants or paper mills. We have this case in point green chemistry, where we have sources of synthetic pollutants in the water coming from farms, paper mills, or other industry or sewers. Here we have a look at what ground pollution looks like and everything that can affect groundwater pollution, whether that's deep well injection of hazardous waste, gasoline storage, septic tank, artesian wells, landfills, streams, and then things from actual compounds. Water pollution in other countries. So we have a Lake Maracaibo in Venezuela. It's 10,000 drilled platform oil wells tap the lake bottom, and this can leak oil into the lake, and then agriculture waste from local fields can enter the lake. And until recently, raw human waste was actually polluting the lake as well. Italy, we have a river in Italy similar to the Mississippi River, lots of pollutants, but about 17 million Italians depend on that river for drinking water. So cleanup will require a huge national management plan, and many will take decades. The Ganges River in India is used for bathing, washing clothes, but it's also being dumped with sewage and industrial waste. There was a Ganga action plan initiated by the government, which was to construct 29 sewage treatment plants near the river to try to clean some of that water. Zimbabwe, in 2 years, between 2008 and 2010, there was a cholera outbreak due to, just dirty water. It caused about 4,000 deaths. And some of this is due to uneducation about the cause of the disease. In Bangladesh, we had an arsenic poisoning, which caused much problem as well. Purification of the drinking water. So how does water get purified? Well, it usually comes from a reservoir, which is held up from a dam, taken to a water supply system, input to the sewage treatment center, and then back into the wastewater where it's treated and then eventually let go. So that's kind of how we can purify some drinking water. In the US, most municipal water supplies are treated. They're collected from a water or a reservoir where they're treated and then distributed to customers. Sewer lines bring sewage to the treatment plant, and sewage is always treated at a sewage treatment plant. The chlorine dilemma, you've probably heard of this. So chlorine byproducts are actually linked to numerous cancers, miscarriages, and birth defects. Peru actually stopped using chlorine altogether because there was a huge cholera epidemic that infected 300,000 people. Fluoridation, 70% of US drinking water has fluorine in it, which is used to prevent tooth decay, but it is believed to potentially be linked to cancer, kidney disease. Although current studies do not show this, I'll let you guys form your own opinion about that. Primary treatment versus secondary treatment of municipal sewage. So primary treatment is removing suspended and floating particles by mechanical processes. Secondary treatment involves treating wastewater biologically to decompose suspended organic material. So this is a little bit look at what municipal sewage treatment looks like. Sewage sludge, tertiary treatment are excess processes that come off of that. And you can see in the primary, secondary, tertiary treatment how and where we remove all of these harmful products. People have individual septic systems, and that's when they take their own household sewage. There's a manhole, and then it basically is its own treatment center, and the treated wastewater goes to the drain field. So you can see these individual septic systems and then going to the drain field. The drain field will then filter out all impurities as the water seeps through the soil. Laws controlling water pollution. We have different acts, 1974, 1972, that tried to set limits and standards for drinking water and cleaning up the water. And different laws that protect water are shown here, which are good. Thanks for listening to this chapter on water pollution, and we'll see you for the next chapter.